we are going to do an example of goodness of fit hypothesis testing. And I'm going to do the example of the coin, which I had in one of my earlier videos in this section, which had 32 heads and 18 tails. And we want to know if this is typical or if this is unusual. Okay, so our null hypothesis, always the distribution is normal. The alternate is always saying it's not normal. The x squared or chi-squared and the df and the p-value we're going to get from StatCrunch. So we just got to figure out what we're going to get for this problem. All right, so let's go ahead and show StatCrunch. All right, so you're going to open up StatCrunch. And the key is, and you can see it, hold on, let me zoom in. You can see that what you want to do is you want to put your data, so if it's a coin, if it's a die, whatever it is, just do it in a column all the way down. So if we were doing a 6-sided die, I'd have 6 entries from the rolling a 1, rolling a 2, 3, 4, 5, and all that. So you don't need to label heads and tails, or 1, 2, 3, 4, 5, 6, okay? You just need to basically input the row of data as a column and name it. Okay, once you've got the data in, we're going to go stat. We're going to go to goodness of fit, chi-squared test. Okay, now we're supposed to select the column. So what that means is that our coin data, our die data, whatever it is. Now, if we had it weighted strangely, like if we expected the coin to be 60% heads and 40% tails, or some sort of weird weighting, then we would want to click the select column. Instead, we're going to do all cells in equal proportion. Okay, anytime you're talking about a coin, a die, in my notes there's an M&M problem, we're going to assume that they are equally distributed among all the different groups. Okay. I'll go ahead and highlight expected because I want it to show the expected counts, and I'm going to hit compute. All right. What you're seeing is that these are the observed counts, and expected, we expected to be 25 and 25. Cool. Now I'm going to copy down the df, the chi-squared, and the p-value. So for this problem, the df is 1, the chi-squared is 3.92, and then my p-value is 0.0477. All right, let's copy that down. So the df was 1, the chi-square was 3.92, sorry about the shadows, and the p-value was 0.0477. All right, we are barely less than 5%. So if we are less than 5%, that means that we are going to reject the null. What? So according to this data, the distribution is not normal. Okay. What that is saying is that something weird's going on. Either we just had some weird data, or our coin is actually weighted heavier on one side than the other. Okay, what's probably happening is it's just some funky data. Okay, but again, according to this, we're just confirming that, yeah, the distribution's not normal. You shouldn't get 32 and 18. But notice we just barely missed it. Okay, now I'm going to do one more video that shows how you would do weighted data. Okay, weighted data. So if we had it weighted differently. So that will be the next example.